So this talk is about the value of reliability, which raises the awkward question, can it be valued at all? I talked a fair bit about this in my 2021 keynote, and I feel we haven't made that much progress as an industry, as will shortly become clear. But the questions we might have under the heading of talking about the value of reliability are, how do we evaluate downtime? What are, in some sense, higher value bits of the stack as opposed to other bits? How could we prioritize engineering effort in line with value? And I think a really crucial question, which is how can we communicate, how can we articulate the value of reliability to other kind of stakeholders, customers, so on and so forth. So let's have a talk about the conventional answer to these questions. I will say that there is such a thing as the standard model, which existed from this year to this year, which is total lies, but let's just say it's true for the moment. The first thing we do, of course, is we assert that reliability is the fundamental feature. We assume that there's some kind of e-commerce or otherwise financially engaged kind of website that we are attempting to assess the value of downtime in particular. We say the time spent on this thing has attributable dollars in some sense. If we miss a request or miss a second or miss some period, we assume a total dollar loss for that period, for that request. We sometimes use averages or we smoosh things together in order to get some kind of thing that's slightly easier to calculate than actually doing the whole work required to answer this question correctly. May well be a fair trade-off. And in essence, this amounts to area under the curve loss. So for folks who work in ML or who study other related disciplines, this is a term of art. When I was on call for Amazon in circa 2005, 2006, and I had to do my first correction of error, which is post-mortem term of art back then, this is the kind of algorithm they used. Now, this model has a number of ways in which it is possible to critique, right? So every model is wrong, every model has flaws, etc. I think one of the kind of emerging understandings is that not everything that's done on a site is equal. Not every request kind of matters the same. I mean, one example would be health checking versus actual customers doing stuff. Of course, health checking is important, but does it yield immediate dollar value in circumstances where that actually applies? No. Another question which I've been thinking about a lot recently is, for that model where you're going, okay, we were out between 1 and 2 and we lost these kind of requests under the curve, etc. Is the total number that you arrive at an upper bound or a lower bound for the loss? And actually, I think that question's much harder to answer than you might think, because you go, okay, in the simplest possible approach, we lost all those queries, so therefore this is an upper bound, like we set all that revenue to 0. But of course, that's not entirely accurate, and sometimes, as we'll see, users come back, etc. So is it a lower bound of loss? Anyway, it's a very difficult question to answer. As I say, users come back, but right now in the industry, my impression is the standard answer, the conventional answer model for how we do this, still can't really answer fairly fundamental questions, such as how many of them come back? When do they come back? On what schedule? There's really an industry-wide kind of dearth of info here, which there might be some hope if we investigate, for example, user churn stats or stuff like that. But I think back-end folks don't often have direct access to that information, or there's potentially some cross-team stuff that has to be done to answer this. And also, I heard a wonderful story the other day about some of the weirder behaviors of customers in outage scenarios. So this particular story is in a gaming context where a gaming company running an online game decides to compensate its users with kind of in-game vouchers for digital goods in the case of an outage. So of course, if you really want that sword, what you want to do is to crash the system so that you get the digital voucher so you can buy the sword. So you can actually have an actively hostile user population that is trying to crash your stuff in order to get the vouchers that you said you would give them if you crashed the stuff, which are compensation for the stuff having been crashed. I'm sure that loop makes sense to somebody. But also, websites don't often or don't necessarily have to have attributable dollar per second kind of values. And they still also have value in some sense. For example, if the Central Statistics Organization website for Ireland, or I suppose any country, went away indefinitely and people were unable to access statistics, there would be some kind of societal loss. How do we measure that? Do we have a good way to do that? No, we do not. Following on from the 100 horse-sized ducks, yeah, no, other way around. Anyway, following on from the recognition that actually, again, this model doesn't necessarily help you to compare kind of different outage sizes or characteristics in some sense, you can also get websites that are incredibly important for an extremely short period of time and then not at all. So a website that allows you to upload your bid for a 5G spectrum auction or something like that, where you're saying $10 billion and it really matters whether it arrives in this second or not this second. So we also can't model that very well. And of course, not everything's an e-commerce website. I hear tell about this ML thing, pipelines, batch processing, etc. The standard model has nothing to say about those, essentially. And also, approaches which are very strongly, shall we say, mechanistic, don't really handle intangibles well, don't really handle questions of user trust very well. And I think this is an increasingly important phenomenon, as we shall see later on. And I suppose also in some sense, when we're talking about articulating the value of reliability, calculating it in this way feeds into the impression that you can treat an online service as if it's a mechanistic or a mechanical kind of model. It sits in the corner, churns out money or PDFs or whatever the hell it does. And the simplest thing to do is to restore it to service, so you don't really have to think about the value it provides, the interaction with the customer, so on and so forth. No real way to make progress in a more accurate understanding of what its role is and how it can be better supported. So I see, when I talk to people, and I'm involved in some discussions around kind of emerging models for how to change this or how to develop this. I think the first thing that I see is, so many of us come from a back-end kind of world, and we're accustomed to thinking about and owning, kind of modeling reliability in a back-end focused way, which generally speaking means loads of services, all of which have measurement numbers or metrics and hopefully SLOs and so on and so forth of that kind. But those don't really add up to a coherent understanding of the user experience. The famous nines don't matter if the users aren't happy. And so I see a real push for customer user journey focused kind of ways of understanding things. Which is, as I say, not service focused necessarily, but trying to center the idea of what we're measuring on the user and what they're trying to accomplish with the service. Also known as jobs to be done. And I suppose if we reflect on this, we end up asking the question, in most organizations, back-end teams own reliability, right? Like that's why we're here, kind of. But why is that the case? Like, should it be the case? Should there be a better bridge between users and back-end folks? I think there's a lot to explore here. Another trend that I see when I talk to folks is way more user behavior aware. And so people are trying to build models, maybe not that accurately, but trying to build models around user backwash, which is to say you have an outage, the users come back, or at least most of them hand wave at some point. This model is often based on previous trends in the company in question and maybe some possibly naive idea of the weighting of the importance of the critical user journey, et cetera. But it is important to note that this kind of thinking is starting to emerge. Also, folks who are at the bleeding edge of this kind of stuff are generally what I'll call SLO mature, which is to say that they have SLOs for sure. Maybe they've thought a very large amount about the appropriate numbers, communicated them in the organization. But having SLOs is extremely important, but also there are extremely important weaknesses with the model. And that thing I said previously about we have a giant outage affecting everyone, or maybe it's short, or we have a long outage which affects partial segments of the user population. Like those are very different experiences for the user, often for the back-end services as well, though we do not track the happiness of the back-end services. Anyway, and also in the world we are now in, we are also cost aware as well as revenue aware, which is to say it's important to track revenue and cash throughput and so on and so forth for the services that admit of this kind of thing, but we're also now starting to pay attention to cost. In some sense, you could argue that a lot of these bullet points, or a lot of these trends are driven primarily by improving the accuracy of the area under the curve measurements that we're doing. You can think of that in terms of, I suppose, backwash measurement in particular, but also improving our idea of what the value of reliability is crucial. So I see a couple of new approaches that are very, very emerging. And there's one in particular, which is call stack labeling, which is basically like pprof, like CPU profiling that you do for your application, but for revenue. So exactly the same kind of approach that you use where you construct a call stack and you attribute a measurable quantity, quality to each of those things, and then you tot it all up at the end and go, okay, it turns out that most of my time is spent in SSL or ML or something, this particular function. Okay, fine. You can actually do the same thing for revenue, except of course, most of the time when you do that, storage ends up owning everything, which is good for the storage folks. But there are emerging approaches that allow you to kind of partition that up in interesting ways to suggest where the bulk of the value and the effort should go. Also looking at SLOs in particular, so extending SLOs to support concentration measures. So one of the things about SLOs is that typically speaking, one number SLO reporting, okay, you said your target was 4 nines and you're 3.5 nines or something like that. The difficulty with that number, of course, is that it doesn't tell you anything about the exceptions. And if you have a sufficiently large user population, popular website, number of requests, et cetera, even making 4 nines means that the proportion of failures could be a very, very large population. But slightly more importantly, it could be a very, very large concentrated population, which is to say that the inverse set of your successes could be like Tim. And Tim's been trying 1,000,000 times to do this thing and it just won't work. That scenario is very bad for Tim. Tim will probably not use that website anymore. It is also bad for the company if the laser of death moves from Tim to Frederica to whoever. And so there's a measure of concentration of the failures, which is useful for understanding where to put your effort with respect to what's going on. It's a little bit analogous to when you do your ping and it tells you the standard deviation of the latency value, because if that's really big, you're going, okay, that's possibly a problem because there's high variation. And so you want to understand stuff about the variation in the failure set population. Or in other words, what matters is whether or not the failures are concentrated in some way. So that brings us to the question of prioritizing engineering effort. So the usual approach is, of course, to beg. You beg for non-functional requirements for the time, for engineering time on non-functional requirements. Or sometimes you sigh and do it yourself. That, I suppose, we're in a lucky position, some of us, if we are able to do that. Or, really sophisticated organizations have some notion of the blended stack ranking of impact of non-functional fixes over revenue, total footprint. Okay, fine. Many of those intellectual frameworks for stack ranking these things are maybe a bit dodgy, but better than random, probably, maybe. There are different ways to do this, of course. So one different approach is based on a phenomenal paper, which I think has not really gotten the attention it deserves, from Microsoft, which is about the A/B testing framework they used on Bing, which you can find there. So it turns out that when the folks who are doing websites in general and are trying to improve some metric, they typically have an idea. They go, oh, we'll put this in blue, or we'll make this font +1 size, or we'll add this feature. And there's degrees of increasing sophistication about the ideas and concepts they have that go towards improving some metric. Very closely connected with the idea of, well, I have a backlog and I have features in the backlog, and product said that this feature is a really big requirement, really of really big importance for customer X. So it turns out that only 1/3 of ideas, attempts to improve metrics, etc., actually improve the metrics that they were supposed to. What happens to the rest? Well, if you launch 10 ideas, it turns out about 1/3 of them do what you thought they would. About 1/3 of them are neutral, which is to say they've no effect whatsoever, hang around in the code base, taking up time, storage space, etc. And 1/3 of them are negative. Negative. They cost more, or they disimprove the metric. So, I'm not saying the product is going to like this argument, but if a randomly selected feature from the backlog has 1/3 percentage or 2/3 percentage chance of being neutral or negative, and you have a fix, non-functional requirement, which prevents a significant enough problem, etc., then the fix will win in total expected value. And we could, of course, obviously extend that to a rational stack ranking scheme, as per my previous conversation, though again, I won't necessarily say that product will like it. But it is important to note that I think many of us in the reliability community, or shall we say non-functional community, often have this impression that the backlog is something we can't touch, or we can't make an argument that other people will understand about the value of what we're doing, because measuring the value of what we're doing is often so difficult. But actually, you can turn that around and you can go, well, measuring our value might be difficult, but measuring your value turns out to be extremely hard / bad. And actually, we're all kind of bad at it. Though we do run into the problem of valuing reliability, as discussed at the start. So one of the other nuances here that's important to note is that the experiments framework during which, or in the scope of which this understanding was arrived at, it primarily benefits you by allowing you to back out of bad things quickly, because in some kind of software development things, you have maybe 6 months to ship, or there's a long period during which you're trying to get feedback about it, but A/B experiments allow you to get that feedback quicker. Interesting to think about the question of incidents, postmortems, and feedback loops in that context, as opposed to the feature feedback context. So these activities actually have quite a lot in common with them, and we should use, in some sense, the same intellectual framework to deal with them. Okay, so communicating the value of reliability. Old approach. Reliability is a fundamental feature. So in some sense, that can be a conversation stopper, right? You're asserting it. It's a blank statement. It doesn't, like, there's no movement forward. Now, as it happens, I believe that. As it happens when Andrew Clay Schaefer writes, the software has no value if the software is down. Like, I think that's true. But if you tease that apart a little bit, how often in distributed systems is software totally down? The answer is, well, it's not often totally down, so it has some value. Like, we're teasing apart the Boolean into a real number in some sense, or having a different model. And also, reliability is the fundamental feature as a kind of a talking point with communicating the value. Well, you either encounter people who are persuaded immediately by the assertion, or people who are not persuaded also immediately by the assertion. And so you need kind of more sophisticated tool sets. And in some sense, I suppose you could also argue reliability as a fundamental feature is a zero interest rate phenomenon statement, in that it applied in a world we'll talk about in a moment. But also you can say kind of less cynically, there is a big difference between something that you're trying to create or grow and something which is already established, for which reversion to the mean is kind of an easier task generally rather than construction. So there are some new approaches as well, not all of which I agree with. And a complex argument, but I think I'll try and illustrate it with some experience of my own. Basically, when there's no prospect of serious growth, making the future customer experience better is worth less than sitting there and extracting money from your existing customers. Okay, so back in the day, I used to work on a system where it was a customer support system. Every quarter, it took in more email than the sum of all of the previous quarters. Like Fibonacci system, right? So you're going, oh my God, like I have to buy a lot of disks. This was in the era when people had disks. So the difficulty, or I suppose the opportunity presented by that is, no matter how much you have been bad in quarters 1 through n, quarter n plus 1 will afford you the opportunity to be better than all of the previous quarters, and the total number of people touched by your reliability efforts will be larger. Okay, that's awesome. But once that's no longer the case, then your reliability efforts touch the existing population, and so they must be weighed against other feature work. Or, to put it extremely strongly, more strongly than I would, there is no econo-rational argument for reliability other than chasing the minimum reliability level, which would cause your customers not to abandon the site. Which is, in essence, the Roko's basilisk of SLOs, right? So don't look that up. Or Twitter, right, where there's lots of cultural pressures to ignore kind of the obviously bad things happening with the site. Anyway, there's a new approach, which I think is the backlog is bad and full of errors or tears. And so we can make an argument about value because we understand at least the statistical value of some of the elements in this set, and we can make kind of comparisons. Another piece of communicating the value of reliability is who you communicate to and how, right? So we often end up talking to execs of some kind. Execs, very simple people, model things primarily by numbers and relationships, okay? And often execs are very busy. In a previous employ, I was walking beside an exec as they went from meeting room 1 to meeting room 2, and they were on their phone, both textually and audibly, while they were doing this, and they made like 3 decisions in the 4 minutes it took to walk between those two, right? So this is their life. So if you are making an argument to these people, and it has to be processed in the 4 minutes between meeting room 1 and meeting room 2, numerical arguments are cleanest, right? 6 strictly greater than 4, we should do 6. Okay, like, hard to disagree. But numerical arguments are cleanest beneath the complexity threshold. If the argument goes above a certain complexity threshold, you can't make the decision quickly. And so things get a bit more awkward. If you can't make it cleanly on numbers, you have to make it based on relationships or power relationships. That can get complex. Well, I agree 6 is higher than 4, but I have to talk to Josephine in order to do that, and Josephine's not very fond of me right now, so we're not going to do your thing. But if you can put the argument in a different domain, perhaps it will pass. Net, if you're arguing for reliability with execs, do try and keep it numeric. That's often a strength of ours, right, when we're communicating numerically. But also, I think a thing we don't quite as often do, connect it explicitly to the customer experience, or acronyms you may not be familiar with in the business domain, such as cost of goods sold, customer acquisition cost, all of these things, which are relatively easy kind of conceptual things to understand, but more importantly, they're in the business domain that the exec deals with all of the time, so you're using the language of them to communicate with them, and that is generally more effective. Also, something else that reliability folks are generally good at is building kind of cross-team or cross-company kind of coalitions of support. So if you can't win in the numerical domain, or it's complex, or it's difficult in some other sense, you can try and put it in relationship terms. If we ship this fix, then ERS will be happy. Very unlikely that ERS will be happy. But if we ship this fix, ERS will be happy. And so you can build a coalition of support across company, and when you have multiple voices in the room speaking up for you, that's generally really, really convincing to an exec-style audience. So I'll leave you with this parting thought. I look around at the world, don't know about you, but I look around at the world and I see reliability is kind of in retreat, really. Like our day-to-day experiences is not of reliable systems. Maybe the things we work on, of course, they're reliable, but other things maybe less so. We also see this as a signal in tech company layoffs and so on. The folks that are chosen to be laid off for processes which do involve a choice. And a widespread belief, I think particularly amongst the exec class, but maybe elsewhere as well, that growth is over. And so if meaningful growth is over, then is there much point in reliability? We also see widespread catastrophes, and even since these slides were written, another catastrophe across every segment of society, ranging from, death and war and all kinds of horrors to excrement floating in streams and all kinds of stuff. But there are those, such as us, still remaining behind the scenes, still trying to keep it all going. And in that sense, even though understanding and representing our value continues to be an ongoing challenge, it's even more important than ever. In an atmosphere where keeping things going is being defunded. Users are therefore, and I mean users of anything, users of the sea, Mike, users of transport systems, users of everything, they are now being conditioned effectively, like I'm not saying this is necessarily a deliberate outcome, but the systemic result of this kind of stuff is that users are being conditioned to accept gradual disintegration or a normalization of deviance, if you've come across that phrase. And so the nature of perceived reliability is changing. Like if you clicked your fingers and every website in the world, or service or whatever, right, became 1/9 less reliable, we're in that kind of territory where it's hard to compare your experiences before with after. And so I feel reliability is becoming a luxury good. It's something which is not for common folks. It's something which is edging towards exclusive across a wide range of things. So how can we fight this? How can you help? Well, I'll come back to some of the things I said earlier in the presentation, which is we don't have good numbers in the back-end community about user experience, churn, backwash measurements. All of this stuff is locked up really, really tightly in silos. It would be great to get it out and to prevent reliability from becoming a Rolls-Royce. Thank you very much.